Here, secreted away in a hangar, is a revolutionary aircraft, the world's first airborne directed energy weapon, the airborne laser, also known as the ABL. The entire nose section is removed and retrofitted to hold the enormous turret-mounted laser in place. The ABL system is designed to find, track, and destroy an enemy target in the air and on the ground. It can loiter at 40,000 feet for 5 hours and destroy a target 60 miles away in less than a second.
You have only a microsecond to respond, and so the laser is almost instantaneous. The laser itself has a speed of Mach 300,000, so it's 300,000 times faster than if I launch a missile from an aircraft. It will be aircraft at a distance being brought down by laser beams.
The weapon is projected to be combat-ready by 2015.
Spends about $1 billion annually developing directed energy weapons, such as high-energy lasers and high-powered microwaves. These weapons can disrupt or destroy their targets at the speed of light. For example, DoD has developed high-energy lasers that have successfully shot down drones, but speed isn't their only advantage. They're also less expensive per use than traditional weapons like guns and missiles. Despite those potential advantages, DoD has had trouble getting these technologies out of the lab and into service. The Army has developed a detailed transition plan to support moving these weapons into the next stages of development. We recommended that the Navy and the Air Force develop similar plans.
Lockheed Martin produces systems that do everything from detect the threats, to identify the threats, determine whether it's a threat to the aircraft, and then employs the appropriate weapon, in this case, a laser weapon system.
What we're hearing from our customers is that they need a layered, multi-domain defensive approach that can be integrated across platforms to neutralize these threats across all those domains. Imagine an aircraft equipped with a laser system with the capability to be able to neutralize a threat at the speed of a lightning strike, the precision of a surgical scalpel, with the magazine to deal with a swarm, and with the scalable effect to be able to address that threat, providing an effect all the way to one end from simply deterring it for a short period of time, all the way up to completely neutralizing and defeating that threat.
We were able to integrate our laser weapon system, Athena, into the classified C2 network and receive cues from the radar on the range in order to execute the full kill chain.
The Helios laser weapon system builds on 40 years of combat system engineering and radar excellence. That is a fundamental change for laser weapon systems, which here to date have been prototypes added to a ship. Helios will be integrated into the ship.
So what's exciting about this technology is that it's scalable. It's lived in the laboratory for many years, but has finally reached the power levels and the effectiveness to allow it to be used on the battlefield. As an example, today's laser weapon systems can be used to defeat rockets, artillery, mortars, and even small UAVs. And as that technology and capability scales, the effectiveness scales with it. We'll be to the point here shortly where we'll be able to defend aircraft against incoming missiles and even reach out over long distances and destroy ballistic missile threats.
Laser weapon systems are earning their way onto the battlefield. Lockheed Martin advancements in the fundamental subsystems, be it beam control, high energy laser, beam direction, power and thermal, is bringing a system-of-system approach to our customers' most challenging problem. Lockheed Martin can bring that end-to-end capability into the theater for the life of our platforms and help defend the brave women and men who boldly go in harm's way to defend our freedom.